Hello everyone, my name is April Milloway-Axton. Today I'm going to share with you my research findings and highlights on the Hubble Space Telescope and the James Webb Space Telescope. Let's begin. So the Hubble Space Telescope was developed and named after a famous astronomer, Edwin P. Hubble. It was a collaboration of NASA and the European Space Agency with several federal contractors involved. This telescope is located 332 miles above the Earth's surface. It orbits about 15 orbits per day. It cost around $1.5 billion and has a lifespan of over 30 years. There are 5 goals of the Hubble Space Telescope, which you can see below. They include examining stars, galaxies, black holes, and dark matter. Also providing a long-term space research facility for the astronomy community. The launch date of the Hubble was supposed to be in 1983, however, there were management issues occurring at the time, delaying the project, and then the Space Shuttle Challenger exploded in 1986, delaying NASA further, pushing back the actual launch date of the Hubble Space Telescope to April 25, 1990. This telescope was actually a part of the Space Shuttle Discovery mission, and it included 5 astronauts and the telescope, and they deployed from the Kennedy Space Center. This telescope includes a Cassegrain reflector with a primary and secondary mirror, and it can see a width of a dime from about a distance of 86 miles, and you'll see more parts of the instrument of the technology listed. This slide shows you a photo of the telescope design. If you click on the link, you can learn more about each component of this telescope and what its objective is to assist with the data collection. This is a few photos of the Hubble Space Telescope team. There are actually thousands of people involved in supporting both the development as well as the ongoing maintenance and activities of these missions. And these team members are located in Maryland, California, Texas, Florida, and Alabama. The team is responsible for the health, safety, and performance of the spacecrafts that support the telescope and maintenance and the telescope itself. They assist with adjusting the spacecraft's subsystem, flight software development, the engineering of the control center hardware and software, as well as systems administration. There's actually a separate team at the Space Telescope Science Institute that helps with scientific aspects of the missions of the Hubble. The James Webb Space Telescope was named after the second NASA administrator. It was an international collaboration as well between NASA and the European Space Agency and several federal contractors, which are listed on the slide. This telescope is located 1.5 kilometers away from Earth. It orbits around the Sun, which is a little bit different than the Hubble, and it actually stays in line with the Earth to be able to protect it from the heat and the light of the Sun. The initial cost of the James Webb Telescope was $10 billion, and its lifespan is predicted at up to 20 years. There are also several goals of the Webb Telescope: searching for galaxies, thinking about what occurred after the Big Bang, how do galaxies evolve, what are the formation of stars, and a really interesting part of the Webb scientific missions includes studying planetary systems for the possibility of life or the potential for life. The launch date of the Webb telescope was on Christmas Day in 2021. It launched from the Ariane 5 rocket, and it was the location of the launch was actually in Europe, and the reason for that was its proximity of the launch site to the equator, so that the Earth's spin could assist with the launch of the telescope, which you can see in the pictures on the slide. This slide details the technology of the James Webb Telescope. It actually has a large infrared telescope that weighs 6,500 kilograms. It has a 21-foot, 6.5-meter gold-coated primary mirror with 18 hexagonal mirrors, which is very large in relation to the Hubble telescope mirror. And again, additional components of this technology are listed. Of great interest are the cooling features of this telescope because of its proximity to the Sun. The Webb telescope team includes 1,200 scientists, engineers, and team members located in Maryland, California, Texas, Alabama, and Ohio. And this mission operations team is responsible for operating the mid-infrared instrument, supporting the detector and mirror technology, providing observatory and test facilities, and supporting the cooling components of the telescope. So let's talk about the scientific findings. Hubble was a huge technological advance of its time, and this telescope was able to use deep field imagery to capture data of galaxies, black holes, and dark matter. Prior to the Hubble, the age of the universe was difficult to calculate, but as a result of the Hubble, researchers have been able to measure galaxies within 10% uncertainty, and those calculations have led to the ability to date and age our universe at 13.8 billion years. Hubble's been used to explore other galaxies such as Andromeda, which is very close to our Milky Way galaxy, and the research from the observations of Andromeda has led to discovering gas and halos of gas that surrounds these galaxies, showing that this galaxy kind of ebbs and flows and grows. In fact, it now has been located about 1 million light years away or halfway to our Milky Way. And the research being done on this galaxy through the Hubble has helped us predict a potential collision between the Milky Way and Andromeda in about 4 billion years. The Hubble has also been used to study Jupiter and its moons. In fact, it has been discovered by the Hubble that one of the icy moons of Jupiter has little to no atomic oxygen, and during the noon hour, when the equator of that moon warms, there has been water that has been located on this moon. There are also magnetic fields located on some of these moons, which make Jupiter moons an ideal place of exploration for past life, current life, and/or the potential for future life. Hubble's also been used to study white dwarfs, and the reason for this is because both the Hubble and James Webb are now used to study white dwarfs, because the studying of these areas are a great way to predict when cosmic events will occur. So if studying the dwarfs can predict when events occur, then you can predict future events and study those events in real time. The James Webb scientific findings and missions have been a little bit more structured and directed. In fact, the Space Telescope and Science Institute director has 13 missions that must be completed first for the Webb. And then a peer review process led to Cycle 1 scientific studies to include 570 programs selected by proposal and application. But some of these 13 initial missions include chemical evolution of ice, studying galaxy formation, studying certain systems, seeing how far the range of the Webb can go, and thinking about exoplanets and exoplanetary systems. So with the Webb, there's been an interesting discovery of galactic merging. So there are two spiral galaxies recorded in the constellation of Serpens, and you can see that in the image, that are merging. And there are also tidal tails that have been found to occur near galactic mergers. And using this data, scientists can look further into the universe to see other galaxies that are merging. And this is important back to the idea of the Milky Way, Andromeda, galaxies merging. How does that impact our galaxy and future galaxies? The Webb has also found huge galaxy clusters. In fact, there are 7 galaxies in a cluster that the Webb has been able to measure the distance, the velocity, and the dark matter. And these specific galaxies have been recorded 650 million years aged after the Big Bang, which is very exciting for scientists so that they can think about other evolutions of our galaxies. The Webb has also been studying sun-like stars and how these stars are formed, and being able to use that data to think about how our sun is formed. In fact, this specific sun-like star area has a region of 50 young stars and is the mass of the sun, so it is very similar to studying our sun. A really important finding by the Webb telescope is water vapor. So the Webb has detected vapor in several areas, but specifically there's water vapor in a planetary system that's 370 light years away. And because of the way the system is forming, the gas and the dust are making ideal conditions for the birth of stars and planets. And in this system, any rocky planets that will form as a result of the dust and ideal conditions for the birth of a planet will absolutely have water on that planet. which is important. So if we can figure out how to get 370 light years away, this is a great area to think about for the potential of our lives and or the potential of other life. The Hubble and the Webb are very similar in terms of a few features. So the similarities are that they help with groundbreaking discoveries. They are supported by NASA and the European Space Agency. They orbit in space. They try to provide clear images of galaxies. The technologies can work together to help scientists. They have longer lifespans than anticipated. They require maintenance costs that were not predicted. And both projects did face challenges. The Hubble had blurry images and the Webb had a cost overrun, making it twice the cost of what the scientific community thought that it would cost. In terms of differences, the Hubble versus the Webb, the Hubble is close in orbit to the Earth. Its mirror is 2.4 meters in diameter. It uses ultraviolet and optical wavelengths with some infrared light. It looks at astronomical objects and phenomena. Its lifespan is over 30 years and its cost is $1.5 billion, while the Webb is further away from the Earth at 1.5 million kilometers. Its mirror is 6 times the size of the Hubble. The data collected starts at the visible light point and then can look at the universe in infrared light. The Webb does not require maintenance by astronauts. It looks at the early universe and the formation of stars. Its lifespan is up to 20 years and its cost is $10 billion. To end my presentation today, I just wanted to provide a few photos to see the differences. So the top two photos, either on the upper corner for one of the nebulas, you can see the Hubble versus the Webb. In image 2, on the left, you can see the Hubble image and the Webb on the right. In the bottom images, you can see the differences in the size of the mirrors on the telescopes as well as the design. And I love this quote. So in closing, with the Hubble telescope, you can see the equivalent of toddler galaxies, but with the Webb telescope, you can see the equivalent of baby galaxies. Here's some videos. So if you click on the link, you can access beautiful videos and images of both telescopes, as well as some missions and how these telescopes can work together to support the scientific community. And lastly, there's just a list of my references. I use several peer-reviewed journal articles by astronomers and astrophysicists, as well as a lot of NASA information. Thank you so much for your time. Have a great day.